Hi, good morning. So let's quick announcement. For your written test number 1, I just need to do some final checks on some details between the two sections just to make sure everything's okay. You're going to see the result and also the answer either later Friday or early Monday the latest. I'll make sure you see the result. And afterwards, you're more than welcome to discuss any question there if you want to go over your answer with me, not email. I don't usually deal with test questions over email. Please come in person, more than happy to help. Either during office hour or just tell me which time you want to meet, and then I'll try to accommodate. Your lab number 1 will be due tomorrow. Don't forget, noon, always the case, right? Please make sure you submit your best attempt, and then I'm going to release a video tutorial solution to you. So you can go over, follow through, pretty much like a Lab 0 Part 2. You can follow through and develop your solution with me. And then your lab number 2 is also going to be released tomorrow on schedule. And that one there is going to last maybe a little bit longer this time. I'll talk about it a little bit later. Lab 2 is going to be more challenging than lab 1 because you're going to use the exceptions. Right? You'll see. I can speak more about it maybe during the scheduled lab session later. All right, any question about course in general you want to ask me before I do a quick recap? We're good? All right. Now, let's now go over some very quick recap because it's somehow relevant to what we're going to talk about today. So last time, we actually summarized or recap about the catch or specify requirements. Especially, we talk about flow, normal versus abnormal. This is so much critical because the lecture that we're going to talk about today is going to have some practical application of the distinction between normal versus abnormal execution flow. If you already understood these two, I'm pretty sure you are, and you should be okay. But we're going to see lots of examples today. And we summarize about how you can use the call stack to understand the catch or specify requirements precisely, right? Just review the part if you have any doubts. And we'll talk about version 1. That was done last Thursday, actually. And we'll talk about version number 2, version number 3, in which case the exception will just be thrown to the console, right? We have seen that in the Eclipse. And we'll talk about more example, basically, like a circle calculator, and also some interesting extension by using a Boolean variable to make sure you can keep prompting the user for the input, right? Also, we can use a try and catch block in between. Dive into the detail of the code, and that's really going to help you. And we're also going to talk about the bank. Slightly more complicated. You can see the call stack. We got 3 methods, but 3 is okay. It's not too bad. And we also got, if you got multiple catch blocks, which we're going to see again, hopefully today. And also we talk about how I can parse the strings into integers using the integer.parseInt method, right? That's also another nice application of using a try and catch block and given your understanding about the execution flow. All right, and then that's a comparison between console messages and error exception, right? We'll talk about it. The main idea to keep in mind, if you're only using console messages to report errors, it's not going to force the caller to do something. So there's no catch or specify requirements. That's the essence of the comparison. Alrighty, so that's about what we talked about last time. Any questions about what we spoke about last time? Any part you want me to repeat or clarify before we move on? Alrighty, okay, let's now cover some new stuff, which will be based on exceptions. Okay, I'll get there. Okay, let's now, I was doing some final, like a major revision on the slides for you guys. So I didn't really post it on time before the lecture, but I'll make sure I do that by the end of today. But I'm going to switch between slides and iPad as usual. Just pay attention. You should be fine. All right, so we're going to talk about test-driven developments with JUnit. It's going to be not a very big lecture. I'm hoping to finish hopefully the majority part of it today. So before the reading week, 1 more week, we can do object equality. So that's the plan. All right, let's see what we should learn in this lecture. Very interesting application about exception. However, what you guys might get confused throughout the lecture is about the execution flow. I'll try to be as clear as possible about the big picture. Again, you have to dive into the code details to see. So we're going to learn about testing. So we're going to use a bounded counter, a very simple counter class to really illustrate the idea. And we're going to give you a little bit idea how you can devising some test strategy. So because I kind of encourage you guys to write your own JUnit test cases. So I'm going to show you one way to derive the test cases. Simple scenario. And this will be the main learning outcome for this lecture. We want to know how to, again, distinguish between normal versus disrupted execution flow, depending on whether exception does not occur or occur. And this is also very important. We're going to look at these two very closely, right? So whenever you're writing a JUnit test, there should be some intention about the test. Do you expect something exceptional to happen? Or do you expect something exceptional not to happen? Both are possible. So we're going to see examples today. Depending on what your intention is, it's going to impact how the test is going to be written and how the execution will go, and how the test is going to be considered as either pass or fail. So there are many details I need to talk about today. And I'm also going to summarize pretty early in the lecture today this workflow called test-driven development by regression testing. I mentioned briefly this term when I talk about syllabus. So now I'm going to talk more detail and show you some nice diagram. So that's really something I'm hoping you'll put into practice when you do your labs or even your programming test. That's also applicable. All right, so let's set up the context for the example. Let's say there are two kinds of exceptions, meaning that we are going to define two exception classes, which you know how to do. And you're going to practice that in lab number 2. So let's say exception number 1, let's say we have something called value too large exception. And the example we're going to do is a counter integer counter. The value should have a lower bound and also some upper bound. If it goes above the upper bound, it's considered too large. If that goes below the lower bound, it's considered too small. Okay? So one exception will be value too large exception. The other one is value too small exception. Right? Pretty straightforward about the two kinds of errors. And as we are testing the counter class, something I want to preview right away. Whenever you're writing a test, you don't necessarily always want to avoid exception. Sometimes exception might be what's expected. We'll see. Okay? It might seem a little bit weird, what I just said, but you will see that it really makes sense depending on the application or the intention of the test. So as we said earlier, any object that's instantiated from either this exception class or this exception class, they will be subject to catch or specify requirement. Just recall the call stack, right, that we talked about. Either you can do specify as part of the API, or you can do try and catch, right? Nothing new so far. This is some very quick review so that you will know. Right, so there we go. If I forgot, please remind me. So we talk about a specify or catch will specify, right? So the specify choice, usually in the method where the exception is originated, we just do the specify option. In this case, throws, right? As part of the method. So this is the origin of the exception, right? Just to remind you. Origin of the exception. Or it could be that we are trying to call a method where the method might throw some exception. So we are now in the caller context, right? So this one here will be C2 and 2 would be the caller of some method that might throw exception. Right? That's something you actually study for written test 1. Right? Nothing new. Just two examples about the specify option. And in both cases, you can see we simply say throws over here and also throws over here for the method. We propagate the method to the subsequent caller in the call stack. What about the catch option? The catch option, let me see if I include it here. Just give me one moment. Maybe it's here. Okay, a little bit out of order. So the catch option there would be, let's say we are now in C3 over here at main. Let's say that's the method that's the caller. So C3.main is now the caller. And we're calling a method over here that might throw some exception. And what we choose to do is just to include a try and catch block, right? That's another way to handle. Just make sure in the catch block you have to specify the exception that you're expecting to catch. All right? Guys, one thing to note here. You can see here something we didn't really say, but we kind of assume. When you are doing this, we say that normally exception happening is a bad thing. Of course, something might have gone wrong, maybe the input. However, when you are later going to write a test, and the test is going to test the correctness of, let's say, this method over here, you have to think about both scenarios. When the input is valid versus the input is invalid. Okay? I'll elaborate on this very much a bit later. But I just want to let you know, we're going to still focus on this kind of code structure, but it's going to be a different context, which is testing. Okay, let's now move on. Approach number 1, approach number 2, we just went over. And let's now consider a very simple Java class, right? Let's call this class counter. And remember static, right? Global. We have some global variables for the counter class. Let's say maximum value and also minimum value. Let's say it should be between 0 and 3. Very small range. If you go below 0, not good. If you go above 3, also not good. And the keyword final over here means these two are constant. We don't want to change the bounds. They should always be the same. All right? And we got some private attribute, just one, value, counter value. And the counter constructor is just going to initialize the counter value to be the minimum. In this case, 0. Start with 0. And we can get the value, accessor, and more to come. All right? Let's say this is the piece of code we have got so far. It's not exactly completed. We haven't got things like an increment or decrement, for example, right? How do we increment the value for the counter? How do we decrement the value of the counter? So this class so far is partially completed. Partially, not completed yet. But the point I want to make is, as soon as you have already started developing your class, or even before you start developing your class, it may not be a bad idea to start thinking about how you may test the application. You don't really have to wait until you have finished everything in your class and then you start testing. It doesn't work that way. You want to start testing as soon as possible. All right, let's say this is what we have done. Let's go over some concept over here. Private attribute, I mentioned that. And we got static constants and also initialized to be lower bound. And now this is the requirement we want to make sure we follow. If you satisfy this requirement, it's good. If you violate it, it should be considered as a failure. So the counter value should always be within 0 and 3. All right, that's a requirement I want you to remember for this lecture here. All right, we're going to base our test and implementation on that. Okay, let's now talk about, well, we haven't really finished the class yet, but it's now already a good timing to think about what might be the exceptional scenarios for manipulating this counter, right? Now, one principle for you guys to take away, right? So you really want to design a test strategy or start designing a test strategy even before your code is completed. We haven't even seen the increment or decrement method just yet. We haven't seen that. But now we can start thinking about it already, right? Sketch on your paper, or maybe you can try to maybe write something on Eclipse, just to think about how your test case are going to look like. Right, so this will be my question for you. Based on what we said earlier about, let me show to you, give me one moment. This will be my question for you, okay? You can ignore the diagram over here, don't worry about it. So the requirements we have is this. The value for the counter should be in between, less than or equal to, larger than or equal to the min, less than or equal to the max. Given these requirements, how many exceptional scenarios are there? Given that we can either increment or decrement the counter. How many exceptional scenarios? How many scenarios are those that we should really throw some exception? How many? Well, give me one. Is a negative number? Yes. So tell me exactly when. Below 0, that you're talking about the value, but what method will be involved? Let's say we can have either increment or decrement for the counter. You're talking about calling which method can cause this exception? Decrement. When the counter value is? Well, the exception should count even earlier, right? Minimum value, yeah. So you were missing just one little detail there, right? So one would be, if the counter value currently is already reaching 0, the minimum value, and you try to decrement it, that should throw an exception. You don't even want to get it to negative in the first place, right? Symmetrically, what can be the exceptional scenario for increment? If you're already in the maximum value and try to increment further, right? So these are the two, right? Makes sense. All right, these are the two, and that's good. We don't need to write any code, but now I want to show you a little bit about how you can devise some testing strategy. So the diagram here is called state diagram. Okay, you may have seen that, or you may have not. That's okay. It's a very standard way to plan state diagram. And whenever I talk about a state, it's really about the combination of variables that you're interested. Not necessarily all the variables in your class, because you may have tons of variables there, maybe some. Those variables you want to get involved in your test. All right? In this case, just the counter value. So you can see the variable we are interested is counter value here, theta value. Theta value here, which can be 0, 1, 2, or 3. There are 4 possibilities, right? So we say there are 4 possible legal states. There are 4 legal states. And we want to consider how can you move between legal states? And also how can you possibly go from legal states and with the attempt to go to some illegal states? So these are the 2 things we want to think about. And typically, the arrow you will see that's pointing to the initial one is called the initial. So this is the initial states. Pretty much like when the counter object is first created, the counter value will just be 0, right? Initial states. And we're assuming that there are only 2 possible updates or methods we can call on the counter object, either increments or decrements. All right? Now we want to see how we can transition between the 4 states. And that should be straightforward. I'll show to you. For example, if I got my initial state to be 0, I can try increments, in which case it's going to move to another state where the value is 1. Right? I can try another increment over here, and it's going to increment the value from 1 to 2, and another one over here. I'm talking about legal transitions only right now. Okay? Symmetrically, let's say I'm currently reaching the maximum, and I may want to decrements, in which case I'll go from 3 to 2. I may want to decrement again. I'll go from 2 to 1. I might decrement again. I'll go from 1 to 0. So these 4, 1, 2, 3, 4, 5, and 6. 6 different transitions. They should somehow be translated into 6 different JUnit test methods. Each one of them should be tested to make sure your counter can really go from one value to another. All right? What about those 2 exceptional scenarios that we talk about? Right? For example, let's say if currently your counter value is already 3, and you're still trying to go for increments, that should be exceptional, should be an error. Versus if your value is already 0, and you're still trying to do decrements. So these 2 are also important. You realize. And I have another important question for you. All right? What do you think will be the difference of the nature of the test? Let's see here. Let's say when we talk about these, let me use a different color. One will be here. Right? All the 6. 1, 2, 3, 4, 5, 6. Versus if I got this one here, Let me use maybe red. If I got this one over here, and also this one over here, these are the same category. Let me just number them so you can see. So let's say this is category number 2. And this one here is category number 1. So category number 1 contains 1, 2, 3, 4, 5, 6 different possibilities. Category number 2 has 1 and 2, right? What should be the difference between these two categories when you try to turn them somehow into test cases? What will be the fundamental difference? I'll give you one hint. What would you expect to happen in terms of exception? That's important to note. Let me repeat once more so you can think about it, and I'll take Robert because you raised your hand. All right? The question goes like this. We know that there are in total 1, 2, 3, 4, 5, 6, 7, 8 possible ways to increment or decrement your counter. We can divide them into two categories. Category number 1 will be this and this. Category number 2 will be all the 6 over here. What's going to be the fundamental difference in terms of the expectation or intention of the test between these two categories? Robert, go ahead.
All right, so for number 2, the illegal ones, you would be asserting that they are like outside of the range. So you would test to make sure just one Boolean statement.
Okay, Boolean statement. Okay, sure.
And then for the legal ones, you would make sure that your expected value is 1 greater than the input value.
I agree. But yeah, I agree. You definitely talk about how we can assert a value, right? Because in this category, you should definitely make sure, for example, if you go from here to here, the value should be incremented, right? And this one should be decremented. And for these two, we don't really worry about the value because it is something more important. But we're still missing some important component in the answer. What about exceptions? What kind of expectation do we have regarding those two, value too large and value too small exceptions in these two categories? What about exception? I want to hear something about exception. Okay, let me put it more precise, more explicit. It's important because we're going to use this concept for the rest of the lecture. All right? Which category do you think we will expect some exception to happen? On the other hand, some category, we do not expect any exception to happen. Now you can see the difference, right? Which category do you think we do expect some exception to happen? 2, right? Try to increment when it's max, try to decrement when it's min. All right, so for category number 2, over here, what you really expected, some exception to occur. On the other hand, for category number 1 here, we do not expect exception to occur because we are still okay in terms of the changing the value. Right? It is very important conceptually, right? All right, any question about this kind of a sketch over here? We kind of talk about how many possible updates you should really turn into your test cases. There are 8 of them. That will be the complete test. And we divide the test cases into 2 categories. For category number 1, we will expect no exception to occur. If any one of them occur, that should be a failure. On the other hand, for category number 2, we do expect some exception to occur. What if they don't occur? Failure. Sounds weird, right? If the exception didn't occur, I will consider the test a failure. That's something you want to get your mind around because the expectation of the test is really important, depending on the context. All right, let's now move on. I think that conceptual sketch is very important. All right, let's now move on with a little bit more implementation. Okay, let me show it to you. So now for the counter class, we already talked about this part, about the various basic stuff. These 2 are the methods that we're going to test because let's say we have developed that, and now you're the software tester in your development team. You're going to test the implementation for these two methods. So the first method is called increment. The second one is called decrements. The increment method may throw value too large, exception, may. And decrements may throw value too small, exception, right? And you can try to convince yourself why this is the correct condition, right? To say, we will throw the exception if you're trying to increment when the counter value is already reaching its maximum right now. Versus, when you try to do decrements, it will be considered exceptional if your value right now is the minimum value, right? It will throw the exception accordingly. If there's no exception, you will increment or decrement accordingly, right? So these are the two methods. So now here's the idea. We want to test the correctness of these two methods. Let's say these two methods were given to you as a tester. Let's say you have no idea how they are implemented. You only know from the previous page conceptual sketch what should really be expected to happen. Okay? Hey guys, please. All right, so now let's move on to the next one. All right, increment, decrements, right? And let's now talk about a little more about components of a test, right? We just have more conceptual sketch for you, all right? And for this part here, you can, let's say whenever in a test, whenever we have a test, we have to manipulate the relevant objects, like a counter objects. So guys, please, when you talk to your classmate for whatever thing that's important, you're just distracting me, which will disallow me to really present efficiently. That would be unfair to your classmate, okay? Hopefully I don't need to call you out. Okay, I really appreciate that. All right, so we want to manipulate the relevant objects in this way, counter, right? So we may want to initialize the counter and call increment. That's something we'll see, but this slide here is pretty straightforward. But let me talk about this part here, right? So this is a very simple JUnit test case over here. We want to analyze the different components in there to see how things should really happen. Because now we have two things over here. We got two methods. One will be the JUnit test method itself. The other one will be the method that we are trying to test, under test. That's the normal term. So the method that we are testing will be get value, right? You want to be very clear about the distinction between these two. So let's now talk about it. So this test over here is the JUnit test method. You can think about this as a test method. Versus this one here, get value is the method under test. That's something we'd like to know whether you should pass or fail, correct or incorrect. This will be the method under test. And we can see a little bit more. So here, the 23, right? We spoke about it in lab 0, right? When we do the JUnit test. This one will be the expected return value, expected value. Expected value. And whenever you're calling some accessor, it is going to return back to you some actual value from the method, in which case you want to see if they match or not, right? This will be the actual return value. Right? That's how you analyze, what's going on here. Let's see a diagram here. And then we can see how we define the notions of pass or fail. All right? Let's now do the following. Let's talk about the method first, get value. All right? Let's start with that. So let's say the method under test. So in this case, get value. And we know that conceptually it's going to take some input and also it's going to take some output in general, right? So there will be some input over here and there will be some actual output. When I say actual output, that's whatever implementation given to you and then you try to run it and you will get an actual output, which may or may not be correct, right? So the actual here is really important, right? Actual. That's about the method under test. What about the JUnit test method? Now this guy here is a bit interesting. The way it works is it's going to take the input, the method, and the output, plus another input to itself called expected output and decide whether you should pass or fail, right? How do we see that visually? Let me move this a little bit downwards, and let's now do this. And you also have some test method. And in this case, the name is simply just test. Right? It's going to take several inputs over here. So input number 1 is going to be let me just do dash line. The input to the method we are trying to test. That's input number 1. Input number 2 is the method itself. Input number 3 is what's really produced from running that test method on the input, the actual output. So these are the 3 inputs to the test method, right? And there will be one more. The final input to the test method will be over here. So that one is going to be the expected output. What should be considered as correct? Expected output. So what the test method will do is it's going to run this particular pair, right, between input and also the method and see what the actual output is. And then it's going to compare these two. Are they the same? If they are, pass. If they are not the same, fail. All right? So this one here and also this one over here is going to determine whether it's going to pass or it's going to fail. Now, what could be some example, right? Maybe our expected output is the value too large exception should occur. Does the actual output produce that exception as expected? If yes, pass. If no, fail. Another run. Let's say the expected output is that particular exception should not occur. But the actual output is it does occur. In that case, we should fail because we don't have a match, right? Always remember this diagram over here because now we got 2 methods in 2 different categories. One is the method we would like to prove its correctness, what you're given. The other one is what we write in JUnit framework. Think about them separate conceptually. Okay. All right, any question about this conceptual sketch? Yes?
My question was, like, it was kind of from the thing before, but when we're testing, like, I get there's a difference between throwing an exception and asserting something is false, but, like, wouldn't it be the same thing, or is it better practice to throw exceptions?
Throw exception. So think about whenever if a method throws an exception, it's complaining about the input it is receiving, in which case something got to be done by the subsequent caller in the call stack, right? So assertion failure is basically belong to the JUnit only. Normally when you implement, let's say your lab 1, lab 2, you don't really say assert something in your code. It's a different category, right? So we don't really want to get confused here. So you want to think about from your test method here, which I have some review slides for you, you got to say the various maybe assert true, assert false, assert equals, etc. That's what you got to say. But in the actual method here that people develop, you don't really say assertion because those are for testing only. So in here, you may throw exception if something about the input goes wrong. And for your software to be robust, you got to do something about it. That's why we do exception.
So, the exceptions, if you want to actually handle them.
You want to handle them, yeah.
If you just want to see the values right around, you just use the assert.
That's correct, in the test, yes. All right, you want to really revisit this diagram here, just make sure you understand what's going on, all right? All right, next. Right, so we have, I'm going to show you this. So these are something exactly what we're going to do. I'm going to show you an example. Yeah, a test will pass if the expected outcome will occur because it matches the actual output. It will fail if they don't match, right? Simple principle. But the tricky thing is sometimes the expected output can be a little bit not intuitive. That's why. Let's now take a look. Very quick walkthrough about JUnits. I wouldn't spend too much time because you guys did a lot in the lab so far. So let's just take this as more like a reference slides. You just want to make sure you review the detail. But let's see what might be worth our repetition right now. So JUnit is a very good way to automate the testing of correctness. You don't really want to system that out the print line all the time, right? It's manual. You got to use your eyes to check on the console for the output. JUnit's always automated. All right, so you want to derive a set of test cases like the diagram that we showed to you over here. That's how the derivation, and then you can turn them into a list of JUnit test cases. That's why I say transform. You have to know how to write them in Java. And the JUnit test cases are really just a caller. They are like a calling the method, right? That's being tested, right? Caller, callee. Right, so, okay, so here, success, failure. So these 4 bullet points over here are what we just discussed, right? A test may expect exception to occur, and success and failure should be defined accordingly. Otherwise, if you don't really expect the exception to occur, then the success and failure might be defined differently, right? So you want to go over these bullet points over here. But they basically follow the same principle, which I just outlined over here, right? You got some expected output and actual output. Whether you will get pass or fail depends on if they match, right? Just remember that diagram, right? Those bullet points, just follow that principle. Okay, regression testing, right? I'd like to talk about it specifically. What is that really? The principle is any change you make. For example, you may implement a new method. Maybe you fix a bug in your method, or maybe you do some refactoring because you want to get rid of the smell from your code, right? Any change that you kind of introduce to your software, they must not compromise the already correct software. So that means every time you did some changes to your code, you should rerun all the JUnit test cases to make sure you still get a green bar, right? If green bar occur before the change, but you got red bar after the change, that means the change has done something wrong, right? Let's now take a look at the diagram here very quickly. All right, so that'll be the workflow for regression testing. Let's see. So we got your Java classes over here. So these are also called classes under test. Classes under test. Of course, usually when you say classes under test, you're testing every method within the class. Or you can say, I'm testing only a specific method, in which case you'll say method under test, right? Depends. Right? This arrow here is saying that you may just have to keep extending and maintaining your software. So your development is not like only for 6 months. You may have to do ongoing extension and maintenance. It's very usual practice. That's about the Java classes themselves. On the other hand, you also got JUnit test case, right? Or test class. Right? And based on what you got in the Java, you will have to derive a set of test cases, right? So derive over here can be conceptual. For example, state diagram, like what I showed to you. That's how you derive. And you got to turn them into the valid syntax in JUnits, all right? And once you have got the JUnit test cases, you can now try to run them, right? Exactly the procedure I outlined over here, all right? And then both the method under test and the JUnit tests, they're going to be passed to the JUnit framework. So this one here is going to run all the tests. All right, and of course, you may get either pass or fail. You may get pass or you may get fail. Let's talk about the passing case. If you get pass, what does that mean? That means your software is correct. I'll put in quote. Software is correct with respect to the quality of the tests. That means your test must be covering as much as possible aspects of your software. Right? If you only got one single test, can you say my software is correct? I can say that it's correct, but only with respect to this single test. But if you got 50 test cases, you can have more confidence, right? The more test cases you have, the more confidence you can say. More tests, more confidence. more tests with quality, of course. All right, what about if fail? This is also important for you to interpret. If you got a red bar, that means you got at least one test case that failed. What it really indicates is the latest change you made. The latest change made to the development code. Introduce a new error. In which case, what should we do? Well, we should really go back to the our development classes and then try to extend or maintain and rerun the test again to see if they pass or fail, right? It's an ongoing process for the workflow. So the most important interpretation for you to make is if you got failure, that means somehow your latest development has introduced some error. So this is why incremental development is so important. You don't really want to rerun all your test cases every hour. That'll be too late. Maybe every important small changes you make. Okay? So one final remark. So the frequency of rerunning all tests is important. Ideally, every small logical change. You don't necessarily have to go for every line. That might be a little bit overkill. But I would say maybe every important fragment of your code has been developed. You should really rerun all the test cases. Maybe add more test cases too. All right? It's the workflow about regression testing, right? Very straightforward concept over here, but to really apply it, you need some time to practice and get used to. Because you might have the tendency to say, I just want to start developing my code from scratch until I finish everything. Not really. But I think for your labs, I already kind of encourage you to do that because you kind of develop test cases one by one. So you don't really just develop from scratch from the beginning until the end. You always try to pass more test case before you move on to the next one. All right, regression testing. Any question? Yes?
Can you explain the derived one?
Sure. The derived basically is saying, while you're developing your Java classes, which does not need to be complete, it can be half completed. In which case, you want to think about what exactly am I building? Maybe let's say I'm building a counter. So I would know I should really try to develop my test cases to say they are within the bounds versus outside the bound. You know, that's kind of stuff. And when I say derived. And when you say derive, I don't really mean you have to write JUnit test cases right away. You can sketch down the idea and transform them later. Mm-hmm. All right. Yeah, think about this process here and just apply. Okay, test-driven development, the diagram, and then something. Oh, this is another keyword here. You want to develop and run test cases as soon as your classes under development is testable. As soon as you got the project compiled, you should really run test cases. All right. Okay, very quickly. So this part here, I'm going to let you review. You don't even need to read it. Just keep it as a reference point. That's how you create Java projects and also how you create a JUnit test case, right? That's something you have been doing ever since the course starts. So I'm just leaving there as a reference point. Right? Java library. And then, oh, one thing to know, though, is this one here. You can see, I'm not sure if you notice, whenever you create your JUnit test case from Eclipse, it's going to give you some default tests, right? And then did you ever wonder, what's line number 7 here? Fail, right? Number 1, fail here is an assertion, like a assert equals, fail. Fail here is always fail, unconditionally, as if you say assert true, false. Okay, I'll write it down. And then we can have some very simple question to be answered to see the point. Yeah, for now, you can just ignore this, just for now, okay? So this will be some default test case that's going to be generated for you. So you can think about here, whenever you say fail, of course, you can pass some string arguments. Either you pass some string argument here, or you can simply say fail. That's fine too. It's overloaded. right? You don't need to pass any string argument. If you want to, feel free. So the fail here would be equivalent to just say assert true, and then you simply pass a false value. Well, if you want to play with it, you can say assert false, but you simply give true, right? Similar idea, but you see the idea, right? It would always fail unconditionally. So this is more like a reminder for JUnit test framework to say, initially we give you one test, but that one just fails. You have to write something to make things pass. Question for you. For this default case, what would be the simplest way to make this test pass? Of course, you can write a counter, right? Counter object manipulation, but that requires more line. Is there an easy way, easiest way to make this test pass? Currently, it failed. What's the easiest way to make it pass? You only need 2 characters to make it pass. You ever try? All you got to do is // Do you know what I mean? Now put that into comments. That means the assertion is not there anymore. So when you run this test here, it's going to do nothing. When your test does nothing, no assertion failure, no exception thrown, nothing. No news is good news. That's really how you pass a test. So remember I said for regression testing, the quality of your test is so important. Let's say you simply copy and paste this test 1,000,000 times, so I will pass 1,000,000 test cases. Does that mean anything? Not really. So quality is important. All right? Guys, let me repeat the point. The point is the simplest way to pass a test is do nothing. Because doing nothing is not going to give you any exception or assertion failure. But it's not going to be very low quality. Right? But conceptually, you should understand why it is the case. And this will be some principle for us to understand over here, right? Assuming that for every JUnit test method, you're going to write some assertion, compare expected value with the actual value. So this will be the principle. Okay, I'll go over with you. A test is going to be considered as failure if either you got some assertion failure. It could be just fail unconditionally, but you don't want it. Sometimes you want it to pass, right, if you got something right. It could be by fail, by assert true, assert equals. That's pretty much what we have been doing for the labs, right? Another possible way to fail a test is if there's any unexpected exception, right? Like a null pointer exception will be array index out of bound exception, or any other exception that's not handled. That's something I'll explain a little bit later. But the main thing is unexpected. So if you run into null pointer exception, array index out of bound exception, that can also fail the test. Okay, I'm pretty sure I have seen that for many of you. What does it really mean to be a success? A test will succeed if there's no assertion failure and also no exception thrown, which is why if I simply got rid of this, it will just pass. All right, remember that principle, which is not difficult to understand. Just remember, if nothing unexpected or nothing bad happened, the test will just pass. But you got to make sure your test method should be filled out with meaningful assertions. All right, that's the principle. Think about it. All right, let me move on. And we got to get to concrete example very soon. But I need to set up the context and pave the ground for you so you feel more comfortable. Yeah, I would say when you read through the slides, I think up to now it's very standard about JUnit tests. Just pay attention to line number 7 to understand why you will fail by default and how to fix it. And this one, easy. And this one's fine. And how do we interpret the JUnit test? Basically, red bar or green bar, right? That's something also similar to what we said before, right? The principle. Oh, that's exactly what I showed to you, actually, on the iPad page, right? All right, after running all the test cases, if a green bar, everything passed. Good. And when you do regression testing, after some change, you rerun all the tests. If you got a red bar, at least one error that should be caused by your latest change. then you should fix your code and rerun the test. Make sure you get a green bar again. Yes?
So with the fail, the string
Yeah.
displaying like
Okay, good. Yeah, so the question was, how is this string going to be used? Okay, that's a good question here. So let's say, well, I can tell you that you may want to use fail assertion in some of your test cases in a meaningful way, but not just by itself only. But that's something we'll see. The question was, how is this string going to be displayed? So let's say if I got some assertion failure over here, if I really failed this one here, you can give it a try. Run this JUnit test, and in the JUnit test report pop-up menu there, it's going to show this message here somewhere. You'll see that. So this way, just to kind of show you where the assertion failure is. You can pinpoint that very clearly. Because sometimes you may have multiple fail assertions in your test method, which we'll see one example, in which case, if I simply say fail without any message, I wouldn't know which one I really failed. But if I can have some meaningful message here, I can know exactly where the cause of the problem is. Okay, we'll see that. All right, that's good. Easiest way to make this pass, comment it out. Okay, and then, yep, the same principle. Okay, common assertion. So we got assert null, assert equals. This will be just for integer. And for double number, maybe I'll talk about it very quickly. I think I mentioned that I forgot either in this section here or the other section, but I'll repeat it. Also assert. Okay, for this one here, you don't need to really use it in the lab, but it is available in the JUnit framework. Feel free to look into it. It's documentation. You can try. Assert true, we have seen that. Assert also fail only. Okay. Right, I got two sets of examples for you. The first set, very simple, just using point. And this one is indeed kind of covered in your lab 0 already. So let's not waste time in the class. You can feel free to go over this. I got all the answer for you here. If you got any trouble understanding it, let me know. Right, but it should be something we covered already. So we don't need to repeat again. Okay, example 1 should be straightforward. Example 2 is about the assert equal doubles. That's only one thing I would like to mention quickly. I'm going to leave this page clean. You can feel free to download it, print it out, and try to see whether there should be an assertion pass or failure, one by one. And you kind of consider it in isolation, right? Because if one already failed, you wouldn't get to the other one for execution flow, right? It's a different problem. Just this one very quickly. We got a circle, we got a radius, right? You know the example. Let's say this. What does it really mean? When I say assert equals here, I'm saying when I say see the get area, I'm expecting to see this. So this will be something that's expected. And then this will be something that's actual return, actual. And this is something we call tolerance. In some context, it's an epsilon. All right? So what we are really asserting over here is like this. What we are really doing is the C dot get area, is it within the boundary of the expected minus tolerance and also expected plus the epsilon. So we are allowing some tolerance on the double value, right? Plus and minus. Okay, that's basically what it means mathematically, which is easy to understand. If you try to compare two double values in the assert equals without specifying any tolerance, JUnit is going to complain, right? You cannot compile, just to let you know. But if you compare integers, it's okay. All right, any question here about this? All right, for completeness, we should understand this assertion. Okay, so we got more assertion methods. I'm going to leave the table here, but I think here, if you can read it, assert same, assert not the same. That's something we'll talk about next week when we get to object equality, right? But I'll keep the page here. You can feel free to read over the documentation, and I'll try it out together with you next time, next Tuesday when we get there. Fine. Let me just do one more slide, and then we can take a short break, and we can do some examples. So this table here really corresponds to the 8 different cases I put on the diagram, right? That's just another way to devise your test cases, right? So here I'm being a little bit more explicit about what I really expect to happen. I'm saying this, for example. Let's say if the current value, C.get value is 0, you can see the first row here. If that's 0, what's going to happen when I say C.increment? I would expect the value to go from 0 to 1. That's something I should assert equals. Versus, if I try to say C.decrements when the value is 0, I should really expect value too small exception, right? That's how you read it. And maybe not finishing off today, but at least I'm hoping to get through maybe at least 1 or 2 test cases. Here's the deal. In class, I'm going to talk about how to turn this one here, and this one here into JUnit test methods. And we'll go over them about the intention, expectation, pass-fail, all together. And then if you want to do some extra practice, you should really try to convert the remaining 5 different entries into test cases. That'll be your exercise. All right, that's what we're going to do. And we're just going to see whether we should get a green, I'll do that on iPad, on paper. But what's so important is to see for individual test method, what's really the expected outcome. That's so important, right? We'll see that. Okay, so why don't we take a very short break for 2 minutes and take attendance at the same time. Okay, get your mobile. All right, so far we set up the context about test cases and also intention, pass or fail. Now we should be ready to consider some very concrete example. And then there will be 3 test methods I would like to show to you. Hopefully we can do 2, I'm hoping. But once you see the first one, you'll see how the other one should really go. The third one is slightly more extended. That might take some time, maybe next Tuesday. All right, one more slide, and then we'll see the example. Okay, so this bullet point here is very important for you to know. The real value of a test method is not just to reaffirm you got something correct, but more valuably, it should be able to reject error when it occurs. Meaning that if there's some if there's some error or defects in your implementation, if your test can reveal it, that's good. All right, that's important to understand. So every time when you're writing a test cases, don't think you're trying to prove that your software is correct. Think it the other way. I'm trying my best to really prove that my software is wrong. If you try so hard, so many test cases, but you still got a green bar, then most likely your software is correct. You see the mindset different? Yep. All right. This method here, don't worry about detail. We're going to go over them. But what I want to, when you review the slide, the reason I want to show this to you is, let's say the method you're given for decrements is actually wrong. Okay, this is wrong. To see why it is wrong, I'll leave that to you, but we're going to try it together. Okay. If, for example, I give this method to you to test, if your test method is good enough, it should be able to reject this method here. To say, no, I'm sorry, you're not correct. I should really give you a red bar. All right. But we're going to see example one by one. Yeah, a good test should really reject such an incorrect implementation, right? But we're going to see that. Okay, let's now take a look at example number 1. I'm basically talking about this test method here. Let's take a look quickly. So we have test increment after the creation of the counter. It goes like this. We first create the counter objects, and we assert equals to make sure the counter value in the beginning is simply the minimum value, right? And then, because we know the C.increments potentially may throw the value too large exception. Because of the catch with specified requirements, we have to wrap it around in the try and catch block. And you never want to say the test method throws some exception. No, you don't want to do that. That's weird. Because you're trying to test something, you should really handle everything by the test method. Okay? So I'm calling this method here, right? Let me just make an annotation for you. This line over here may throw the value too large exception. Okay? And we know pretty well from before, if I'm able to reach this line, what does that mean? That means the exception did not occur. So the execution flow was not disrupted. All right? So reaching this line means no exception occurred. No exception occurred. It is important. On the other hand, if you're able to reach into the catch block, what does that mean? That means this particular exception occurred, right? So these are the two possible execution flow, right? Reaching the catch block means the value too large exception occur. Right? You really want to make sure you still understand either reaching this line or reaching the catch block. Okay, these are the two possible flows, right? And now what we want to do is this. We want to somehow compare the same piece of code, the same method, and then I'm going to give to you two versions of the method under test. Version number one, the method is implemented correctly, okay? And the same setup for all the other two tests. So think about this one here is going to be version number one of the increment method, which I'm going to give to you, right? On the other hand, the other version, version number two of the increments is going to contain some bug. Version number two of increment. Now, let's think it this way, okay? The setup for the test is going to be like this. Since we are only trying to say, I want to initialize the counter to be the minimum value, and I just want to increment it, and this should really corresponding to the value from 0 to 1. No exception should be expected, right? So now that's why you see expected behavior in this case will be calling increment when the value is the minimum should not trigger a value too large exception. That'll be the expected behavior. We do not expect any exception to occur. So what does it really mean for the implementation to be correct? Correct simply means no value too large exception thrown from this method call. That'll be the correct implementation, in which case the test should pass. On the other hand, for version number two, over here, the value too large exception will be thrown unexpectedly. And in this case, the test should fail. All right? We haven't really looked at the logical structure for the test just yet, but we're going to do that. That's going to be done when we do the tracing. All right, recap for the concept here. For this particular setup for the test, we're trying to increment the counter only once, where its value currently is the minimum value. And the expected behavior is the value should go from 0 to 1. And there should not be any exception, specifically value too large exception occurring. Now, if the implementation you're trying to test is correct, meaning that it is not going to throw that value too large exception, and also it's going to increment the value, then you're going to pass for the test. On the other hand, if the implementation that your teammates give to you somehow threw that exception unexpectedly, in that way, your test will only be a good test if it's going to fail on this incorrect implementation. Right? That's what we're going to understand very well conceptually. This will be test number one. Test number two, we're going to flip the expectation. Right? Let's hope today we can at least finish one test. Okay, let's now consider case number one. All right? All right, guys, so this will be the same test, the same. All right? And this will be the correct implementation. All right, let me just annotate. I think today just finish just one test. I think that'll be good enough. So this is the correct implementation. Specifically, you can see we only try to throw the value to large exception when the value is currently the maximum value. I think increment, yes, that's correct. Sorry, I was confusing myself. Because we're calling the increment method over here, right? So increment should only throw value to large exception if the current value is maximum, right? That's correct, all right? This is a correct implementation. So now we prediction of the test result should be pass. Because the implementation is correct, so you should pass, right? Let's now try to trace the code quickly, all right? So we're going to create this counter object over here. And then that one is going to be sure c.value in the beginning will just be equal to 0. You can look back to the constructor, right? It's going to be 0. And when we run this assertion here, assert equals, counter the minimum value, let me remind you, is 0. C.getValue is going to be, from the beginning, also 0. So this one here should be a pass. And then we're going to go into the try and catch block. So we're going to face this method here. At this point, c.value, let me remind you, is simply equal to 0. So when we call this increment method here, all right, value for the counter is 0. What's the maximum? 3, right? 0 equal to 3, false. And we're going to increment the value accordingly from 0 to 1. 0 to 1. So this is why after this, the execution flow is going to go to the next one here and check to see c.getValue is really 1. Indeed, it is. So you will also pass. And we're going to bypass the catch block. Nothing wrong happened. So this will be a pass, right? So our prediction matches. Any question about running this test case over here, right? Remember the principle. If any assertion fail or any unexpected exception occur, you're going to fail the test. Otherwise, it will be a pass. Let me do one more thing. So if you think about line number, steps, 1, 2, 3, 4, and then 5, and then 6, and then 7, and then 8. Okay, just for your reference. All right, that's the steps. Let's now look at the second one, all right? 8 minutes should be good enough, all right? Now, the second one here goes like this. The same test, but now the implementation given by your teammates is wrong. Let's say, let me say I'm going to inject an error to the implementation. I'm saying that for the increments, you will try to throw the exception when the value is less than the counter maximum value. Let's say they are a very careless programmer. They make this mistake. So now, for the same test, it will only be considered as a good test if running this method under task, which is wrong, is going to fail. Right? Let's see. So what we want to say is, this one is wrong implementation. Meaning that test should fail. If the test doesn't fail, it's a useless test. All right? Let's now take a look. Similar idea. Number one, we're going to see the counter value, and it's going to be the value after this will be 0. And then assert equals, initial value should be minimum, the same, it should pass, right? In the minimum value 0, I'll try to be using purple only for the steps. Minimum value is 0, get value is also 0, the same as before. And then step number 3, step number 4, and we try to increment. At this point, right in the beginning, we know that the value is equal to 0. All right? And then we're going to step into the C dot increments over here. So it's going to be number 5. All right? Now, check this condition here together. Value is 0. Maximum value is 3. 0 less than 3, true. Unexpectedly or wrongly, it's going to throw the exception. 6. Right? Meaning that bypass the else. So you can see how wrong the implementation is, right? You're trying to increment when the counter is 0. It shouldn't give you an exception, but it does. And then after 6, we'll get, so now we're going to bypass this, right? Because exception occur. Don't continue anymore. Flow will be disrupted. So we go to number 5 will be the catch block, and we're going to match this exception here. It's going to be thrown. So from here, this one here, the value too large exception thrown. Mistakenly. How about that? This is important for you to see. Value thrown mistakenly, right? After that, we're going to go to number 6, and that one there is going to fail unconditionally. So our prediction that of the test result should be it should fail. And we do have a failure. Fine. So we just prove somehow by 2 alternative implementation, one correct, one incorrect, to show that our test case is good because it passed on the correct implementation and you fell on the wrong implementation. Are we okay? Okay. Let me assign you something to think about, and I'll let you go earlier today. I think you got enough. Okay, just give me 2 minutes. I tell you what the exercise should be. I'm going to make this page to you. Okay. Now for JUnit test case number 2, this will be the setup for the test case, right? So now what we want to do is kind of like an opposite, right? Different. We create a counter still, and then we try to decrement right away. Now, do we expect exception to occur? We do. So now the pass-fail should be somehow defined in the opposite way. So what I want you guys to really struggle a little bit, over the weekend is to think about, for this particular test, how is it going to go define pass and fail on the correct and wrong, incorrect implementation? Right? That's something we're going to continue from Tuesday. But from Tuesday, we can go a little bit faster about this flow over here because now we do understand. And one more thing, and I'll let you go. And you really want to make sure you go over regression testing and also this diagram here. And I think that'll be it. Okay. Thank you so much. I'll see you next week.